Hessian matrix. So Hessian matrix, second partial derivative again. So when we're looking for the second partial derivative, we have to go for the first partial derivative, okay? So we have to find the first partial derivative with respect to all the variables that we have in the problem. So this question here is f of x, y equals to exponential x times cosine y. So we have these two functions that we have here, the exponential function, then the trigonometric function cosine y, okay? So we spice it up a little bit and this is going to be very interesting. All right, so then we said the first partial derivative. So we got to find the first partial derivative. So to find the first partial derivative, this is now the notation of it with respect to x, all right? And then we're going to do it with respect to y. So if we do it with respect to x, so what's going to happen? So that means our target is exponential x. So we're going to find the derivative of that. So what is the derivative of exponential x? It is still exponential x. Now, what do we do with the cosine y? Cosine y is multiplied by exponential x. So as we're going to take this one as a constant, we're just going to have to keep it. All right, so it's not going to be 0. That's a common mistake that people will make. It is equal to 0 when you have a plus or minus sign between these two terms, okay? In this case, it's multiplication, so the constant stays. So it's going to be exponential x, so it's going to be cosine y still, okay? Now, we're going to continue and then find the first partial derivative of that same function with respect to y, okay? So with respect to y, so that means cosine y is what is our target. So that becomes our target. So if this one becomes our target, so that means what? What is the derivative of cosine y? Derivative of cosine y will give us a negative sine y. And what are we going to do with exponential x? We're just going to keep it as that, okay? Because it's a constant again, and because of the multiplication between the two of them, we're going to keep that constant. So that will give us the negative exponential x sine y. Okay? So that's what we have for the first partial derivative. Now we have to go for the second partial derivative. Because we have two variables, so we're going to have a 4 by 4 matrix, or 2 by 2 matrix. Okay? So we're going to have 1, 2, 1, 2. So it's going to be a 2 by 2 matrix. So what's going to happen? So it's going to give us, so we have first partial derivative, so which is going to give us what? Of f. So the second one, okay, everybody, with regard to x again, so that'll give us square, just like that, okay? And then that is equal to what? So now we go back in here. This is the first partial derivative of x. So that's what our target is. So we're looking at here now. We don't look at that. We even act like this doesn't exist, okay? So we get here and then we say, we try to find the second partial derivative with respect to x. So that means we go back and then our target is x there. And then what is then the derivative of exponential x? Stays exponential x. And what do we do with the cosine y? So cosine y is now a constant, so we keep it as a constant. So that gives us cosine y. Okay? So like we did before, this now is the x line, right? So the horizontal line or the row, so that's the x row. So we're going to finish with that. So once we get there, we have, so now it's still x, but now with respect to y. So with respect to y. So that means we're still here. But now we are concentrating on y. Okay? So if we concentrate on y, so that means what's the derivative of cosine y? That is negative sine y. And then what are we going to do with the exponential x? It's going to be a constant that we're going to keep. So it's negative then exponential x of sine y. Okay? So that's what we have for that. And now we have to go for the y row. Okay? The y line. So if it's a y line, so that means what? We have it with y, but now with regard to x. So that means with y, that means this is our function that we're going to deal with. Okay? And then because that's a function that we're going to deal with, we say that we're doing it with regard to x. So that means we're going to look at exponential x. That's our target here. So because that's our target, so what's going to happen? So then that means what's the derivative of exponential x? It stays exponential x. What are we going to do with sine y? There's nothing we can do with sine y. We just keep it, okay, because that will be our constant. So we end up with negative exponential x sine y. Okay? And then, last but not least, we have it with regard to y second, because we're going to do it again for y, but the second time. So we're still here, but we're going to do it now the second time for y. Meaning what? That means we're going to target sine y. And sine y, what's the derivative of sine y? Is cosine y. What are we going to do with exponential x? We're going to keep it as what it is, and the negative sign as well. So what's going to happen? This is going to give us negative exponential x, then cosine y. So this is how we deal with the Hessian matrix. All right, with the Hessian matrix, which is the second partial derivative. And then we go for the first partial derivative first. And what we do after that, we have what we call again the x row, the y row. So for the x row, you take this one here, the first partial derivative, and then you do it the second time with respect to x, and that's what we get here. And then once you get here, you still have the first partial derivative with respect to x. Now you're doing it with respect to y, and then you go with the cosine y, and that's what you get. And now, once you get to the y row, so you have now y, so that means you're doing it with respect to the first partial derivative, with right here. So that's what you do with respect to x first, and then with respect to y after. Okay? So take your time, digest the information, go back to the video, watch it as many times as you can so that you can grasp it and then don't get confused. It's not hard, but it is tedious. It takes a time, but take that time to understand, and once you become an expert, now you can run. Okay?